Welcome to Backspace Academy. We're currently at the start of all the pathways to AWS certification preparation with Backspace Academy. So it doesn't matter whether you're just going to go on and do the Cloud Practitioner certification, or if you're going to go further and do an associate level certification like the Developer or Solutions Architect or SysOps Administrator Associate. This is still fundamental required knowledge for you to proceed any further. So make sure that you don't skip over this and do it. And without any further ado, let's get into it. So what is the AWS cloud? AWS has invested billions of dollars in IT resources that are distributed across the globe. And the use of those resources is shared amongst thousands upon thousands of AWS account holders. Now, although those resources are shared amongst those account holders, the accounts themselves are completely isolated from each other at the hypervisor level. You also have the option of your own dedicated resources if you wish. You as an account holder can have on-demand delivery of IT resources on a pay-as-you-go pricing model with no upfront cost. You only pay for what you use. The more you use, the more you pay. The less you use, the less you pay. When you don't use it, you don't pay for it. When you use it, you pay by the hour or the minute or the second, and some services even provide billing by the millisecond. Now that provides some really good economies of scale because the cost of that infrastructure is shared across thousands upon thousands of account holders. If you're a large enterprise, that is great because you don't have to worry about the capital expenditure of your own infrastructure. And you don't have to worry about the maintenance staff to support that infrastructure. Now that infrastructure is organised according to a range of different product types. If you want to use those IT resources for pure computing power, AWS can do that for you. If you want to use AWS just to store data, AWS can do that for you as well. If you want to run a database as a service, if you want to run a relational database, a NoSQL database, a graph database as a service, AWS can do that for you. And they'll do that on demand on a pay-as-you-go pricing model. The AWS global infrastructure is massive and is divided into geographic regions, and those geographic regions are divided into separate availability zones. As you can see, there are lots of regions distributed throughout the globe. For this course, we will be using the North Virginia region because that is the largest region and supports all of the available AWS services. If you're using a smaller region, for example, Mumbai, you may encounter problems if it doesn't support all of the services. The AWS GovCloud is located in the US West Coast and is specifically for US government organizations. There is also an AWS secret region, and I can't tell you where that is because it's a secret. That region is specifically for US government intelligence organizations, and in case you're wondering, yes, the CIA is a customer of AWS. Your choice of region can depend upon a number of things, and you may want to have the lowest latency, and you want your server to be located as close to your customers as possible. But you may also want to minimize costs. For example, I'm located in Sydney, but I mainly use the North Virginia region because it is cheaper for me. You may also want to locate your server in another country for regulatory reasons, or you may want to be located in your country for regulatory reasons. So there are a number of factors to take into consideration when selecting a region. Each region is divided up into at least 2 availability zones that are physically isolated from each other. This provides business continuity for your infrastructure if you have it distributed across multiple availability zones. If one availability zone goes down, the infrastructure in the other availability zone will continue to operate. The largest region, US East North Virginia, has 6 availability zones. And the availability zones are connected to each other through a high-speed fibre optic network. There are over 100 edge locations that are used for the CloudFront content delivery network. CloudFront can cache your popular content, such as images and videos, and distribute that to edge locations across the globe for high-speed delivery to your end users, no matter where they are located. And it'll do that with very low latency. It also provides great protection against DDoS attacks. The AWS Management Console is a web-based interface to AWS, and we'll use it throughout the course to access AWS services. And you'll also use it to monitor your costs. You need to have an account to access it, but once you have an account created, you can access it simply by clicking on the My Account menu from the AWS website and then selecting the Management Console. There's also an AWS Console mobile app, and that is great for tablets. You can also access AWS resources through the many software development kits. This allows you to create applications that use AWS as a back end. There are SDKs for all the major languages, and there's also a mobile SDK. It's also possible to access AWS with direct HTTP calls using the AWS REST API. You can also install a command line interface on your desktop, and that will allow you to remotely connect into AWS and also be able to create and run scripts to automate a lot of the processes on AWS. The AWS website is located at aws.amazon.com. What I want you to do now is to go to that website and bookmark some pages of the website. The first one is the certification page, and that will have links to everything you need to know about the certification process. So if you're not sure what certification to do, or you want to know how to schedule and sit an exam, that is a place to go. The next one is the documentation page. Throughout the course, we will be referencing the documentation for the services on AWS. So that is a very important link. And the exam, it's going to be testing your knowledge of a lot of this documentation. AWS also has a site specifically for white papers, and they discuss technical issues and use cases for AWS. The products page gives a really good overview of the main products of AWS. And finally, the new products and services page, and that'll keep you up to date on the latest things that are happening in AWS. Okay, let's get started with AWS. First off, go to aws.amazon.com. Click on the orange sign up button in the top right-hand corner and complete that sign up process. You'll need to have a credit card to sign up, but don't be too concerned, as there is a free tier available for a 12-month period, and most of the course will be operating under that free tier. We can also set up a billing alert to alert you if you exceed your budget. For example, we can set up a $5 billing alert to notify you if you exceed $5 for the month. Once you've created that account, you can then get into the Management Console by clicking on the My Account menu and selecting AWS Management Console. Coming up next will be some hands-on labs on AWS services, so make sure that you download the lab notes that come with this introduction to AWS before proceeding any further. And once you've done that, I'll see you in the next lecture. Up next, what I'm going to do is run through all of the products and services that are offered on AWS. Now, there's an enormous amount of services, so rather than go through them all in one hit, I'm going to break it up into a lot of sections, and then at the end of each section, I'm going to give you an example of how to use those services. And then after that, we'll do a hands-on session or a lab where you can actually use those services yourself hands-on. So what I need to do now is just give you a very quick introduction to the different types of cloud computing models that are available. Infrastructure as a service, it contains the basic building blocks for cloud IT. What that means is that is nuts and bolts stuff. So if we want to launch a Linux server and we want to manage that Linux server ourselves, that is how we would do that as infrastructure as a service. And we would do that using the Elastic Compute Cloud or EC2 service. The next level is Platform as a Service or PaaS. And that's where AWS will take a little bit more control over over the underlying infrastructure. So AWS manages that underlying infrastructure and the hardware and operating system normally. And a good example of that would be the relational database service. And in that service, AWS, they provision all the operating system, the server and everything to run that, but you still need to do the high-level administration of that database. And then finally, we've got software as a service or SaaS. And that is a complete product that normally runs in a browser, and it is mostly refers to end user applications. A good example of that would be Office 365 or Salesforce.com. And you'll hear another term used a lot with AWS, and that is serverless computing. And so that allows you to build and run applications without having to think about servers. You don't need to provision the server yourself. AWS will do that for you. It's also referred to as function as a service or abstract services. Examples of that are the simple storage service where we will be using at the end of this lecture, where we create a bucket and we put objects and files into that bucket. We don't know what's behind that bucket. Obviously, there's going to be an operating system, most probably a Linux operating system, a file server, there's going to be hard drives. We don't need to worry about that because AWS, they look after all that for us. AWS Lambda is where you can run code in the cloud, again, without service. You just provide AWS your code. AWS looks after everything for you. DynamoDB is a NoSQL database in the cloud as a service. And Amazon Simple Notification Service that can send out notifications to your users. So that's a pretty quick introduction of the different types of cloud computing models. The best way to really get a good knowledge of it is to go through all these products, get your hands on with them, and then you'll fully understand it a lot better. So there's only one more thing to do, and that is, let's get into it. Welcome back to Backspace Academy. In this lecture, we're going to run through some of the storage services that are available on AWS. Then we'll look at some examples of how you can use these, and finally, we'll finish up with a hands-on lab using one of these services. Amazon Simple Storage Service, or S3 for short, it's designed to store and access any type of data over the internet. It's a serverless service, and as such, we don't need to worry about what is behind it. There's obviously a file server, an operating system, a hard drive, but we don't need to be concerned about that at all. We just simply need to create this thing called a bucket, and then we upload objects to that bucket. The bucket grows as we add objects to it, and the size of that bucket is theoretically unlimited. AWS, it just looks after everything for us. Amazon Glacier is the cheapest storage option on AWS, and it's used for long-term archiving of data. It's a serverless service, just like Amazon S3, but it is not as readily accessible as S3. So it should only be used for content that is to be archived. You can also set up a lifecycle rule that will automatically migrate old data in Amazon S3 automatically over to Glacier for long-term archiving. Amazon Elastic Block Store, or EBS for short, is a highly available, low latency block storage, and it's specifically for attaching to servers that are launched with the Amazon EC2 service. We'll learn more about the EC2 service coming up. And it's similar to attaching a hard drive to your computer at home. Works in the same manner. It's block device storage. Amazon Elastic File System, or EFS for short, is network attached storage, and it's specifically for Amazon EC2 servers. Because it is network attached storage, this allows multiple servers to access the one data source, in a similar way to a NAS on your network at home can be accessed by multiple computers on that network. The AWS Storage Gateway enables hybrid storage between on-premise environments and the AWS cloud. It provides a low latency performance by caching frequently used data on premises while storing the less frequently data in Amazon cloud storage services. A Snowball device is a portable, petabyte scale data storage device that can be used to migrate data and large amounts of data from on-premise environments over to the AWS cloud. You simply download your data to the Snowball device, then you send it off to AWS, who will then upload that data to an AWS storage service for you. Okay, so let's have a look at some examples of using the AWS storage services. In orange there, we've got the AWS cloud. Now, we can create a VPC inside that AWS cloud. And that VPC, or virtual private cloud, is our own private space within the AWS cloud. And that is an impenetrable fortress against attack. And no one will be able to enter our own private space without us allowing that to happen. So let's just say we launch 2 servers in our VPC. Now we want these servers to have access to data and somewhere to store that data. And so in a normal environment, you would just add a hard drive to that server. So in the same way, we can attach an Amazon Elastic Block storage device to our servers. So that's great. We've now got high-speed access to our data. But what if we want that data to be available to both of those servers? So here we've got 2 EBS volumes. What if we want that data to be on one volume only? So as we know it on our computer at home, we can't attach a hard drive or a block device hard drive to multiple computers. It just doesn't work like that. So in a situation like that, in your home network at home, you would just go out and purchase a NAS, a network attached storage device. You would attach it to your network. You would set up your operating system in your desktop computers to have a mount target for that network attached storage. So when you go to your G drive or whatever it is, or E drive or F drive, whatever it is, that will point to that network attached storage. In the same way that we can do that with our network at home, we can do the same thing with AWS. So Elastic File System is network attached storage. And so that, with a mount target, can enable multiple servers to access the one data source. Now, what if we don't want to worry about mount targets and block devices and all this sort of stuff? We just want somewhere we can upload objects to, in a similar way to we do with Google Drive or something like that. And we also want to have an automated solution that over time migrates that data over to something more low cost and more long-term for archiving. Now that is where Amazon S3 comes in. And so we can use Amazon S3 to create a bucket, store objects in that bucket, delete objects, do whatever we want with it. And we can also set up a lifecycle rule on that bucket so that over a period of time, as objects age, they can be migrated over to an Amazon Glacier Vault for long-term archiving. It will still be accessible, it just won't be as readily accessible as the S3 bucket. But the advantage is that we'll be using the lowest cost storage that's available on AWS. Now, that S3 bucket will be located in the AWS cloud. It's not located in our VPC. So remember we said the VPC is our private space within the AWS cloud. And nothing gets through it without us allowing it to come through. So that is where the VPC endpoint comes in. So we can create one of those, and that will allow traffic to flow in and out of our VPC specifically for that S3 service. So let's have a look at a hybrid storage example where we've got on-site storage in a corporate data center, and we've also got that stored in the AWS cloud in Amazon S3. Why would we do that? Well, it's great for a disaster recovery solution because it provides high-speed access to our data in our corporate data center, and at the same time, we're taking advantage of the durability and availability of Amazon S3 as a disaster recovery solution. So the first problem that we're going to encounter is that this corporate data center will have petabytes of data. And to transfer that over via the internet to the AWS cloud is not going to be practical. So AWS, they can send out to us a Snowball device, and that is a high capacity device that can store petabytes of data. And so we can upload, when we receive that Snowball device from AWS, we can upload our data to that, and then we can send that back to AWS, and they will upload that for us into the Amazon S3 bucket. And so that solves that problem for us. So then we've got to find a solution for making sure that the data in our corporate data center is synced with our AWS cloud. Now that's where the AWS Storage Gateway comes in, and that will orchestrate all of that for us. And so if you have got a high-speed link between your corporate data center and the AWS cloud, which you can with the AWS Direct Connect service, you can have the AWS Storage Gateway to orchestrate and manage that all for you. And what it will do, it will get your popular content, your content that is frequently accessed, and it will store copies of that on site in your on-site storage. But at the same time, it will store all of that data in an Amazon S3 bucket for you. And so then you've got the advantage of having all of the durability and availability of Amazon S3 as a disaster recovery solution. But at the same time, you've got high-speed access to your data, which is cached on the corporate data center. Let's have a go at using the Amazon S3 service. So what we're going to do now is that we're going to use the AWS Management Console to connect into the AWS cloud. And then we're going to create an Amazon S3 bucket. We're going to upload files to that bucket, and then we're going to download files from that bucket. And then finally, we're going to empty and delete that bucket. Now, there are lab notes for this lab and the further ones coming up. So make sure that you download the Introduction to AWS lab notes that come with this course, and let's get into it. Now, before we start the lab, you need to make sure that you have signed up for an AWS account. If you haven't, click on the sign up button up here at the AWS website. Once you've completed that sign up process, make sure that you take note of the email address and password that you used to sign up with. So once that's done, you can go to My Account and select the AWS Management Console. Once you've done that, you can log in using that email address that you used to create your account and the password that you used as well. So once you do that, you'll be into the AWS Management Console. Okay, once we've logged in, we'll be at the AWS Management Console. From there, we can go to Services and try and find the S3 service. Now that will be in the storage category. I actually don't like to use these categories because they change quite a bit, and when you're looking for stuff, it might be moved into a different category. So it does make life a little bit difficult. The easiest way is to select up in the top right-hand corner here is A to Z. And then if you're looking for S3, just go to S for S3 and you'll find it there. So once we've got into the S3 console, the first thing we need to do is to create a bucket. Now, I've already created quite a number of buckets here for different labs and whatever I've done in the past, but yours will be obviously empty. You never created a bucket and it's a brand new account. So your screen here might look a little bit different to mine, but there will still be a create button or create bucket button there. So we'll click on that. And we need to give our bucket a name. So I'm just going to put in anything there, just a whole heap of rubbish there, but you can give it whatever you want to call it. Now, a bucket name needs to be unique across AWS. So if someone else has actually used that name, you can't use it as well. So it's a bit like domain names. Once you've got it, no one else can use it after that. So if I, for example, if I type \slab or something, no doubt that would have been gone. So I'll leave that as it is. It's just a whole scramble of letters there. And we'll click on next. We're not going to worry about versioning or anything like that. We'll just click on next. It's going to be a private bucket, so only us will, or only I will have access to this bucket. So we're not going to make it public. We're not going to change anything here. And next. So that's all we do there. It's got our name and region. So we're going to be in the US East region. And for all of the labs, make sure that you are in the US East region. It's the largest region and has the most services. And when services come out, they normally first come out in US East. It's also normally the cheapest region to use as well. So that looks all okay to me. We'll just click on Create Bucket. If I scroll down, I should be able to find that bucket name that I did. There we go. So just that scramble of letters there. So it will have a link to that bucket. So we'll just click on that. And there we can see our bucket is empty. So our bucket, it's simply a repository to dump objects to. Could be files, could be videos, could be a whole directory. So what we'll do now is it will upload a folder to this bucket. So we'll click on upload. Now, we can click on add files here, but I don't like to use that. The easiest way is to drag and drop. So if you're going to bring in a folder, for example, it's much easier to grab the whole folder and just drop it on the form. So that's what I'm going to do now. And we just drop that whole folder onto that form. And we click on next. And it's only going to be access for us, so it's going to be private. We'll leave that as it is. And the storage class, so we've got a number of different storage classes, depending on what the availability is, how long we're going to be using it, how quickly we need access to it, all this sort of thing. So we're just going to use the standard storage class. We'll click on next. And that's just a review screen, and we'll click on upload. So there you can see down the bottom, it's starting to upload those files, that whole folder with all the files inside of it. So now that that has uploaded, we can select this folder, open it up, and we can download a file, get it back again. So let's do that. So we just click on the link in this folder to open up that folder. And I'm just going to download these lab notes. If I click on those, on that link for the lab notes, and I just do download lab notes. And there we go. So that's downloading those that PDF. Now, I just want to talk about this screen because a lot of people have a bit of trouble with this, because instead of clicking on download, they scroll down here and they click on the object URL. Now, if we click on that, and I'll do that now, this is what you get, access denied. So what that is you're trying to access through your browser directly to that object, and it's a private object, so you can't access it. So if you want to have a file that is accessed like that, you need to have it public, and you also need to enable website hosting in Amazon S3. So we'll just get out of that. So if you get that screen, that's what's happened. You've clicked this object URL instead of clicking the download link here. So that brings us to an end. Now, at the end of all of these labs, I like to clean them all up and delete everything that we've done, simply because we don't want to get billed for it. So if you're operating on a new account, you're going to be getting a free tier. And so all of this stuff that we're doing here today will be free. And we just need to make sure that we clean it up afterwards. So I'm just going to jump back and click up the top here to the link to that bucket. And I'm just going to select that folder. I'm going to go to Actions and scroll down until I find Delete. And I'll delete that. And now our bucket is empty. So one more thing we can do, if we really want to clean this up, we can go back into our S3 management console by clicking on Amazon S3 up the top right-hand side there, or top left-hand side. And if we scroll down to find that bucket, and there it is. And then we can just click delete to delete the bucket. So we need to put in the name of the bucket and confirm to delete it. So there we go. If we have a look for that bucket, it's no longer there. So that brings us to an end. And coming up next, we're going to be doing some more looking into some of the services of AWS, in particular database services. And we're going to be creating a MySQL database and connecting to that database. So some pretty cool stuff coming up, and I look forward to seeing you in that one. In this lecture, we'll have a look at the different options that are available for running databases on AWS. We'll then have a look at a database example, and finally, we'll finish up with a hands-on lab where we'll be creating a database server on AWS and then remotely connecting in to that database. The Relational Database Service, or RDS for short, is a fully managed database service that makes it easy to launch database servers in the AWS cloud and scale them when required. The RDS service can launch servers for MySQL, including variations of the MySQL database engine with MariaDB and Amazon's own enterprise version of MySQL, Amazon Aurora. Standard PostgreSQL is also available, and also available as Amazon's Enterprise Aurora PostgreSQL. Microsoft SQL Server and Oracle are also available. Amazon DynamoDB is AWS's NoSQL database as a service. It's a serverless service like Amazon S3, and as such, you don't need to worry about the underlying infrastructure behind it. AWS takes care of everything for you, and it provides high speed, extremely low latency performance. Amazon Redshift is a fast, fully managed, petabyte scale data warehouse that is based upon the PostgreSQL database engine. If you're looking for a big data storage solution, Redshift is perfect for this. Amazon Elasticache is an in-memory data store or cache in the cloud. It allows you to retrieve information from fast, fully managed in-memory caches instead of relying for slower disk-based databases. The AWS Database Migration Service orchestrates the migration of databases over to AWS easily and securely. It can also migrate data from one database engine type to another totally different database engine type. For example, you can use it to migrate from Oracle over to Amazon Aurora. Amazon Neptune is a fast, reliable, fully managed graph database service. It has a purpose-built, high-performance graph database engine optimized for storing billions of relationships and querying the graph with millisecond latency. So let's have a look at how we could use these database services. Let's say we have an on-site Oracle relational database, and we want to migrate that over to Amazon Aurora on the AWS cloud. The first thing we could do is to launch an RDS instance in our virtual private cloud. And remember, a VPC, it's our own private space within the AWS cloud, and no one can enter it without us allowing them to enter. We could use a database migration service to migrate that data in that on-site Oracle database over to a target RDS Amazon Aurora server. Now let's say our new database is becoming overwhelmed with requests for frequently accessed data, and we would like a high-speed way of accessing that frequently accessed data. And this is where Elasticache can help us. We can put an Elasticache node in front of that RDS instance, and that will cache our frequently accessed data. And because it's delivering that data from memory and it's not delivering it from a hard drive, it will be delivered with very low latency. And at the same time, the load on our database will be massively reduced. And any requests for anything that is not in the Elasticache will be simply forwarded to the RDS instance. And that way we have high-speed access to our frequently accessed data, while at the same time, we can still access our less frequently accessed data directly from our RDS instance. Coming up next, we'll be doing a hands-on lab, so make sure that you download the Introduction to AWS lab notes that come with this course. We'll be launching a MySQL database instance, and then we'll be connecting remotely into that database instance.
Okay, so I'm in the AWS Management Console now. We go to Services, to the Database Services and RDS. Now that will take us into the RDS dashboard, but if we don't have any RDS instances created previously, then it will go into a welcome screen like this. So we're just going to go to the left-hand side here, click on Instances, and we're going to launch a DB instance. Now we have a number of options available for our database engine. We have Amazon Aurora, which, as we said previously, is AWS's MySQL Enterprise Class database. And that is not eligible on the free tier, so we're not going to use that for now. And we have the MySQL Community Edition, and again they've got the Amazon Aurora. In case you missed it previously, they've put it up there, but we're not going to use it because it costs us money. MariaDB, again, is a MySQL compatible database. And again, if you missed it, there we have Amazon Aurora as well, which we won't be selecting. PostgreSQL, Oracle, and Microsoft SQL Server. So to make sure that we don't get a bill at the end of the month, we're going to click on this checkbox here saying free tier eligible only. And there we can see Amazon Aurora is not eligible for the free tier. So we go into MySQL and we can see Amazon Aurora there as grayed out again. We can't select it, and we're going to select the MySQL Community Edition. And again, we make sure that we have this option here available. It says only show options that are eligible for the RDS free tier. We don't want to get a big bill at the end of the months. Now, if we scroll down, we have a number of options here. So the only one that we really need to be concerned with is the instance class. So we're going to use a dbt2 micro, which is a pretty small instance, and it's on the free tier. We don't have any other options for storage type other than SSD, where we're working on the free tier, so we leave everything there as it is. Now we go into the settings of our database server. So our database server needs to have a DB instance identifier. It needs to have a name, so I'm just going to call this one \intro-AWS. Now that needs to be unique within your AWS account for DB instances. Next, we're going to create a user, and I'm just going to call the master user admin, and I'll give that master user a password. Now that password has to be at least 8 characters long. So once we've completed that, we've put in our name of our database, we've put in our username for the master user of this database or this database server. And we've put in our master password and we've confirmed that password. We click on next step. Now, we don't need to configure any of these advanced settings for network and security. We just leave the default settings as they are, but as we get more into RDS and other services later on in the course, we'll be getting more involved in this sort of stuff. But for now, we just want to just get our dip our toes in the water or so with AWS. Now, we have an option to create a database on launch with this database server. So we're just going to create a database called test. If we leave it blank, then there will be no databases on this database server, and we can create those later on. But we'll just have one ready to go, and we'll call it test. Now, we don't need to worry about backups because this is just a lab. We're going to be doing it on the free tier. We just don't want to have any hassle with that. So I'm just going to change the backup retention period to 0, and that will mean that it will disable automated backups for the instance. We don't need to worry about monitoring or maintenance. We just leave that as it is. Again, this is just a hands-on introduction to RDS. And then we can launch that DB instance. After a certain amount of time, that will be acknowledged and we can view our DB instances. And we can see there that it has a status of creating, and after a while it will go to being available for use. Okay, so after a few minutes, or quite a few minutes, we've got our MySQL database server on RDS up and running, and its status is available. So the thing that we need to understand here is that we can now connect through to this RDS instance through an endpoint, and that endpoint is here. So we need to take note of that, and the part that we're interested in is the endpoint domain. So everything there finishing with amazonaws.com, and we don't do the :3306. We just select that. So I'm just going to select that now because we're going to be using that later on. Now, before we do that, we need some software to connect into our MySQL instance. So we need to go to the MySQL homepage, and there is a link in the lab notes to this to download the MySQL workbench and install it to our system. Okay, so here I am in the MySQL workbench, and down the bottom there we can see that we have the MySQL connections. And we don't have any as yet, so we just click on the plus sign next to it and we'll add our connection to our RDS instance. So we just give that a name. So I'm just going to call it backspace, that will be fine. Now a host name is going to be that connection string that we got, or that domain that we got from our RDS console, and it's not going to have the :3306 on the end of it. It's just going to have the domain details, the host name details. And the 3306 is our port number, which is already detailed there on the screen. Now, our username is going to be that master user that we set up when we created our RDS instance, and I used admin. And that is all we need. We just need a user, we need a host name, and we need the port that we're connecting on. So if we just test that connection now, it will ask for a password. And we've successfully made that MySQL connection. So we just click on OK and we can add that to there. So once we've created that connection, we can obviously connect into our database. So all we need to do is double click on that. And there we've connected into our RDS database, and we've got our MySQL or our SQL dashboard there set up. Now, if we look down here under schemas, we can see that we have that test database that we created, or that we requested to be created in our launch configure, or when we're doing our configuration for our launch details of this RDS instance. So if we click on that information icon next to test, that will give us some information on that. Okay, and there we can see we've got our Backspace database with a test schema in there. So our server Backspace and our test database inside there. So there we have it. We've successfully created an RDS instance and we've connected into it using MySQL Workbench, which is pretty great. Now that you've successfully connected in using the MySQL Workbench, I'm going to show you how to connect in with the MySQL shell software, and that will allow you to do command line work, such as issuing SQL commands to your RDS instance. So the first thing we need to do is to install or download the MySQL shell, and there is a link in the lab notes to that URL to do that. Now when you get there, just scroll down, select your operating system. If you're on Windows, don't do this installer for Windows. It will install MySQL and all this stuff you don't really need. All we need is this 16.5 meg file down the bottom here. So just download that. If you're on a Mac, it will look something like this. So you will have a DMG archive that you can download and extract after you've downloaded. Okay, so now that we're in the MySQL shell, we can connect into our RDS instance. So the way that we do that is we do backslash, not forward slash, backslash, connect, and then we do our username, which was admin, and then we do @ and then we do that endpoint, our RDS endpoint. So we just jump back into the RDS console, we'll select that endpoint and copy it and bring it over. Now we don't have to worry about removing the :3306, we can leave it there, or we can take it off and it will default to 3306 anyway. We enter our password that we created, and that should connect us in a short amount of time. And there we go. Now what I'd like to do is just issue some SQL commands to the database. So I need to change to SQL mode. So again, we do \SQL. And I can issue a command now. So show databases. Now make sure that you put a semicolon on the end of your SQL commands, otherwise they're just going to hang there. And then we can see we've got our standard MySQL databases there, and down the bottom we've got our test database that was created for us by the RDS service. Now the test database will be empty, so I'm just going to select one of the system databases there, so the MySQL one will be fine. So I just do use, and then that schema or that database that I'm going to use, so MySQL will be the one that I use. And there we go, schema is set to MySQL. Now, when you do that command, make sure that you don't put the semicolon on the end of it, otherwise it'll hang again. Now, I just want to issue another SQL command again, so we can show schemas this time. Well, actually, no, we'll show tables, actually. And that will list the tables for the MySQL database. And there you go. So there's all those standard tables that you would have in there. So we've managed to connect in using the command line interface or the shell, MySQL shell, and we've switched over to the SQL mode and we've run SQL commands. So what we're going to do now is we're going to jump back into the AWS RDS console, and we're going to delete all this to make sure that we don't get a bill at the end of the month. And back in the RDS console, we go to, or first of all, we select our MySQL instance. We go to Instance Actions, and then we go to Delete. We don't want to create a final snapshot, and then we click the acknowledgement that we won't be able to get this back after we've deleted, and we click on Delete. And that will be deleting, and eventually it will disappear from the screen if we keep refreshing the screen here. So there we have it. We've created that instance and we've connected in, and now we're cleaning it all up afterwards. So I look forward to seeing you in the next lab.
Welcome back to Backspace Academy. In this lecture, we'll have a look at the compute and networking services of AWS. We'll then have a look at some examples, and finally, we'll finish up with a hands-on lab where we're going to deploy a WordPress web server using the Amazon EC2 service. Amazon Elastic Compute Cloud, or EC2 for short, provides virtual servers in the AWS cloud. You can launch one or thousands of instances simultaneously and only pay for what you use. There's a broad range of instance types with varying compute and memory capabilities, and those will be optimized for different use cases. Amazon EC2 auto-scaling allows you to dynamically scale your Amazon EC2 capacity up or down automatically according to conditions that you define. It can scale up or down by launching or terminating instances based on demand. It can also perform health checks on those instances and replace them when they become unhealthy. Amazon Lightsail, it's the easiest way to launch virtual servers running applications in the AWS cloud. AWS will provision everything you need, including DNS management and storage, to get you up and running as quickly as possible. Amazon Elastic Container Service, or ECS for short, is a highly scalable, high-performance container management service for Docker containers. The containers, they will run on a managed cluster of EC2 instances. AWS Lambda is a serverless service and lets you run code in the AWS cloud without having to worry about provisioning or managing that service. You just upload your code and AWS takes care of everything for you. So let's have a look at how we could use these services to deploy a web server in the AWS cloud. Here we have the AWS cloud and our virtual private cloud, or VPC, located inside that. And remember, a VPC is our own private space within the AWS cloud, and no one can enter that unless we allow them to enter it. We can launch an EC2 instance, and that can be running our web application, for example, WordPress. So what happens if this single EC2 instance becomes overwhelmed by demand? For example, we might have released a new product and our WordPress application cannot deliver the web pages quickly enough to satisfy that. What we could do is that we could tear down that instance and put in a bigger instance that could handle that demand. And that is called vertical scaling. And that used to be all the rage 10, 20 years ago. But the problem is that it takes time to do that. And while we're doing that, our application is not running. And also, what happens when the demand goes back down again? Do we have to tear that down and then put in a smaller instance? And what happens if that happens every day? What happens if that happens every hour? It's just not going to be economical for us to do that. What we can do is that we can horizontally scale, and we do that by adding more instances. And as demand goes up, we add more instances, and as demand goes down, we terminate those instances. And that way, we still have continuity of our application. Our application will always be running because there's always going to be at least one EC2 instance to look after the demand. One problem with this architecture is that it has multiple endpoints for our web server. And that's not practical because customers are not going to go to one endpoint until that stops working and then go to another one and then another one. It's just not going to work like that. And obviously their bookmarks in their browser are not going to be valid. So we need a way of having one single endpoint for that web application that our customer can go to, and then having a way of distributing those requests to a EC2 instance that is available. That is where elastic load balancing comes in. So it can receive traffic from our end users, and it will distribute that traffic to an EC2 instance that is available. So a request will come in, it will distribute it to an available EC2 instance. Another request will come in and it will distribute it to a different EC2 instance that is available, and it will balance the load across those EC2 instances. And if one of those EC2 instances become unhealthy, it will fail a health check with the Elastic Load Balancer. And then the Elastic Load Balancer will no longer send traffic to that unhealthy EC2 instance. But what happens if that demand is only for a short period of time, for example, half an hour? What do we do then? It's not going to be practical for us to terminate instances when demand goes down and then launch instances manually when that occurs. We can't do that every hour. It's not going to be practical. And that's where the auto scaling service comes in. It can launch EC2 instances automatically when the demand on those instances increases, and it can terminate automatically EC2 instances when the demand on those instances goes down. It can also perform health checks on those instances, and if one of those instances becomes unhealthy for whatever reason, it can replace that instance with a healthy instance, and it will do that automatically without you having to do anything at all. So now we'll have a look at the networking and content delivery services. Amazon CloudFront is a global content delivery network, or CDN for short, that securely delivers your frequently requested content to over 100 edge locations across the globe. And by doing this, it achieves low latency and high transfer speeds for your end users. It also provides protection against DDoS attacks. Amazon Virtual Private Cloud, or VPC for short, lets you provision a logically isolated section of the AWS cloud. And you can launch AWS resources in that virtual network that you yourself define. And this is your own personal private space within the AWS cloud, and no one can enter it unless you allow them to enter it. AWS Direct Connect is a high-speed, dedicated network connection to AWS. Enterprises can use it to establish a private connection to the AWS cloud in situations where a standard internet connection won't be adequate. AWS Elastic Load Balancing, or ELB for short, automatically distributes incoming traffic for your application across multiple EC2 instances and also in multiple availability zones. So if one availability zone goes down, the traffic will still go to the other availability zone, and your application will continue to deliver responses to requests. It also allows you to achieve high availability and fault tolerance by distributing traffic evenly amongst those instances, and it can also bypass unhealthy instances. Amazon Route 53 is a highly available and scalable domain name system, or DNS for short, and it can handle direct traffic for your domain name and direct that traffic to your back-end web server. Amazon API Gateway is a fully managed service that makes it easy for developers to create and deploy secure application programming interfaces, or APIs, at any scale. It handles all of the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. It's a serverless service, and as such, you don't need to worry about the underlying infrastructure. AWS looks after everything for you. So let's have a look at an example of how we can use these networking services of AWS. So here we've got the architecture that we looked at before in the compute section, but one thing we didn't mention was availability zones. So let's just say that we've launched that architecture in a single availability zone. What happens if that availability zone goes down? What happens to our traffic? Our traffic has nowhere to go, and our application stops delivering responses to requests. That is why it's always desirable to have our architecture distributed across multiple availability zones. That way, if one availability zone goes down, the other one will continue to operate and the infrastructure within that other availability zone will continue to respond to requests. We can launch EC2 instances in multiple availability zones, and our elastic load balancing service can distribute that traffic across multiple availability zones as well. So if one availability zone goes down, the elastic load balancer will continue to distribute traffic to the availability zone that is still healthy and to those instances in that availability zone that are still healthy as well. So let's just say our application running on these EC2 instances is a WordPress web server. And that contains lots of images and lots of video that is static content. It's not really changing that much. And it's not efficient for us to continue to keep delivering that from our EC2 instances. We would like somewhere to put that where it can be delivered with high speed and low latency and to take the load off our EC2 instances. That is where the CloudFront Content Delivery Network, or CDN, comes in. So we can get these large images and large videos that are not really changing that often, and we can put that in a CloudFront distribution. And CloudFront will cache that and distribute that across hundreds of edge locations across the globe. So when your end user requests that video or those images, it will be delivered to them with really high speed and low latency. And at the same time, it's going to take the load off your EC2 instances and is going to significantly reduce your costs. At the same time, dynamic content that is changing regularly, CloudFront can forward those requests over to the elastic load balancer, which will then forward them to an EC2 instance. So that way you have the best of both worlds. You have dynamic content delivered as a dynamic content, and at the same time, you have these large videos and images that aren't really changing that often, delivered very rapidly. Now that CloudFront service or that CloudFront distribution will have its own DNS name that we can put into a browser and we can directly access that. The problem with that is that that DNS name for that CloudFront distribution will be something very complicated and just won't mean anything to our end user at all. So we would prefer to have our end user type in a domain name and have the requests for that domain name forwarded to that CloudFront service. As you can see here, we've got example.com, and that is where Route 53 domain name service can come in. So Route 53 will grab those requests for your domain, example.com, and it will forward those requests over to the CloudFront service, and the CloudFront service will handle it from then on. So let's just say we work for a large enterprise that has its own corporate data center. And the reason it's got its own corporate data center is because that is located where the employees work. And we don't want our employees to be slowed down by a network. We want them to be able to work efficiently. But at the same time, we have resources on the AWS cloud that those employees also need to access. So we need some way of having a high-speed connection between our corporate data center and the AWS cloud. And that is where the AWS Direct Connect service comes in. And that can provide a very high-speed fiber optic network between our corporate data center and the AWS cloud. And that is completely private. Okay, so that's a very complicated architecture, and don't be too concerned if that's very overwhelming, because if you're going on to become a cloud practitioner, you're not going to need to really be able to produce this yourself. As an associate level certification, that is a different story. You'd be expected to create this yourself. But cloud practitioner, you'll need to know what these services do. You'll need to know that Route 53 will forward requests for your domain name to a back-end endpoint. CloudFront will distribute your content to hundreds of edge locations across the globe. Elastic Load Balancer will receive requests and distribute those requests to multiple instances across multiple availability zones. A virtual private cloud is your private space within the AWS cloud. The AWS Direct Connect is a high-speed fiber optic network connection between an on-premises corporate data center and the AWS cloud. If you understand that, then you're well on your way to passing the Cloud Practitioner exam. Okay, so coming up next, we're going to have a lab. So make sure that you download the Introduction to AWS lab notes that come with this course. So what we're going to do is that we're going to launch an EC2 instance, and we're going to select an Amazon machine image of a WordPress web server. And that will allow us to deploy a WordPress server on the AWS cloud. And then we're going to be able to go to our browser and view our website that was created by that EC2 instance. And we're going to do that all through the AWS Management Console on our desktop computer.
Okay, so in the AWS Management Console, we go to Services, we go into Compute Services, and we select EC2. Now that will take us into the EC2 dashboard. If you've never used EC2 before, you might be presented with a welcome screen, but just go to Instances on the menu here and click on Instances. And we're going to launch an instance. Now we first need to select an Amazon machine image or an AMI. And that is a template that contains the software configuration, the operating system, application server, and applications that are required to launch an EC2 instance. We can select an AMI provided by AWS from the AWS user community or from the AWS marketplace. Or we could also select our own AMI if we've created an AMI previously, which we obviously haven't. So we're going to go into the AWS marketplace and we're going to search for a WordPress AMI. So they're the WordPress powered by Bitnami. That will be fine for us to use, so we'll select that one. And we're going to select the T2 micro instance because it is free tier eligible, which means that if we create this instance and then we shut it down afterwards, we're not going to get billed because it's on the free tier. We have a whole heap of other options that we can do, but we're just going to go into the configured instance details, and the only thing that we need to change here is to auto assign a public IP. So we need to have a public IP address for this EC2 instance so that it can have a presence on the internet and so that we can access it through a web browser. Now, there are a whole heap of other options that we can look at, but this is really just an introduction to AWS. We're going to do something very simple and the most simple thing that we can do right now. We're not going to get into discussing any of this stuff because we're going to go into quite in-depth detail on the EC2 service and VPC and a whole heap of other stuff further through the course. So for now, we're just going to click on Review and Launch and accept everything that we've got there. And we just click on Launch. And instead of choosing a key pair, we're going to proceed without a key pair. And a key pair is used to connect directly into our EC2 server. And we're not going to be doing that, so we're not going to be connecting into the Linux operating system, but normally you would, and normally you would download a key pair and you would use that to connect into your Linux server. But for now, we're not going to do that. And we just acknowledge that we will not be able to connect to this instance because we don't have a key pair. And we launch the instance. So after a certain amount of time, it will go through its process and will be returned to the EC2 dashboard. And there we go. So we just click on View Instances. and our instance will come up with a status of pending. Okay, so after a few minutes, our EC2 instance status or its instance state has changed to running. And that means that we should be able to see our web server on the internet. So if we've selected this instance and we look at the details of this instance, so we go down here and we can see that it has been assigned a public IP address. So when we're configuring our launch for this, we did select to create a public IP, and that is a public IP address that has been created. So if we go to that, we should be able to see our WordPress application. Okay, and there is our WordPress application, and looks great. So we can't really do much with it now because we need to be able to administer our WordPress application. We need to be able to log into this site and put web pages on it and whatever. So the people at Bitnami, what they've done is that when this EC2 instance launched, they created a username and password and they embedded that in the logs of our EC2 server. So when it was launching, there will be a number of logs that will output information. So we just need to go into those logs. So we'll go back into the EC2 management console. Again, we've selected our EC2 instance. We'll go to Actions. We'll go to Instance Settings. And we're going to get the system log. Okay, so there's the system log. If it first doesn't come up, you just need to give it a bit of time. Just go away, have a cup of coffee, come back, and the system log will be there. It doesn't automatically just come up straight away. Sometimes it does take a bit of a while to come up. So we just scroll down until we find the section where it has our details. So here we can see we're setting the Bitnami application password to that. So we just need to copy that password. So we just copy. And we'll just close out of this. Now, if we go back into our user's blog or into our blog there, and we just go to that IP address again, and we go to admin. And that'll take us to the admin section, and we'll need to put in a username. So the user will be user, and then we just need to paste in that password and log in. Okay, so there you can see, we won't remember that password. So there you can see that we've logged into our administration page of our WordPress application. So we can do whatever we want. We can add some pages in here. We can go into pages, add new page if we want. We can do whatever we want as we would with any WordPress application. So that's how we launch an EC2 instance or an EC2 server to create a web server. Now that we've achieved that and we've created these resources, we're not going to need them anymore. So what we're going to do is we're going to get rid of them. We're going to delete them all and terminate these instances. So what we'll do is go back into the EC2 management console. We'll go into Actions, and then we're going to go to Instant State, and we're going to terminate that instance. And it's just giving us a warning saying that, do you really want to do this? Yes, we do. So yes, terminate. Okay, so after a certain amount of time, and it will take quite a bit of time, that will go from shutting down to terminated. So that's all that we need to do now. So again, there's a lot more to the EC2 service that you need to know. But for now, I think you've got a good idea of how it all works. So it's now your turn to go and grab the lab notes and do it all yourself, and I'll see you in the next one.
In this lecture, we'll have a look at the different management services on AWS. We'll then finish up with a hands-on lab where we'll use the CloudWatch service to implement a billing alert on our account. CloudFormation allows you to use a text file to define your infrastructure and to use this text file to deploy resources on the AWS cloud. This allows for the defining of your infrastructure as code, and you can manage your infrastructure with the same version control tools that you use to manage your code. The AWS Service Catalog allows enterprises to catalog resources that can be deployed on the AWS cloud. This allows an enterprise to achieve common governance and compliance for its IT resources by clearly defining what is allowed to be deployed on the AWS cloud. AWS CloudWatch is a monitoring service for AWS cloud resources and applications that are deployed on the AWS cloud. It can be used for triggering scaling operations, or it can also be used for providing insight into your deployed resources. AWS Systems Manager provides a unified user interface that allows you to view operational data from multiple AWS services and to automate tasks across your AWS resources. That helps to shorten the time to detect and resolve operational problems. AWS CloudTrail monitors and logs AWS account activity, including actions taken through the AWS Management Console, the AWS Software Development Kits, the command line tools, and other AWS services. So this greatly simplifies security analysis of the activity of users of your account. AWS Config enables you to assess, audit, and evaluate the configurations of your AWS resources. This simplifies compliance auditing, security analysis, change management and control, and also operational troubleshooting. AWS OpsWorks provides managed instances of Chef and Puppet. Chef and Puppet can be used to configure and automate the deployment of AWS resources. AWS Trusted Advisor is an online expert system that can analyze your AWS account and the resources inside it, and then advise you on how to achieve high security and best performance from those resources. Okay, let's have a go at using one of these management services. We're going to use the Billing and Cost Management Console and the CloudWatch service to create a billing alert, and that will notify us when our account has exceeded a budgeted amount. And it will do that using the simple notification service, and we'll learn more about the SNS in the next lecture. Okay, so starting off in the AWS Management Console, the first thing that we need to do is that we need to enable billing alerts on our account. So we go to our account up here and we select My Billing Dashboard. So from our Billing and Cost Management Dashboard, we'll scroll down and we'll go to Billing Preferences. And just make sure that you've got here that you're going to receive your invoices by email. And you'll also see a checkbox here, which is already checked for me because I've already enabled this, but for you, it won't be. So you need to click on this checkbox. It will then set up a process for you to authorize billing alerts to be received on your email address. So then you just simply save preferences. Once we've enabled our billing alerts on our account, then we can go into the CloudWatch service. So go to Services and then CloudWatch. And what we can do is we can set up an alarm that is going to be triggered whenever our account exceeds a certain level in dollars. So we just go to Alarms and we create an alarm here. We need to select a metric. And we have a number of metrics to select from. The ones that we want are billing. Now, if you find that your screen doesn't look like this, it is not that the video is wrong. It is not that the lab notes are wrong. It is that you are not in the US East North Virginia region. That is the only region that you can be in to set up billing alerts on your account. So we click on Billing. And the one we want to look for is Total Estimated Charge. So we'll click on that. We'll select US dollars and we'll select that metric. Now what we need to do is we need to specify the conditions around how this alarm is going to be triggered and what's going to happen when that alarm is triggered. So we specify the metric and conditions. So we'll just scroll down. So it's going to be a static one. So it's going to be triggered whenever the value exceeds a certain limit. So it's going to be whenever it is greater than, and we'll just put in there $10. Because pretty well everything that we're doing so far will be on the free tier. So if we get anything going above $10, that should alert us to being a problem. And we'll click on next. So now we're going to come to where we need to configure the actions for this alarm. So what is going to happen when this alarm is triggered? What's going to happen when our account exceeds $10? So what we need to select is that in alarm. So whenever it exceeds this level, it's going to go into an alarm. So what happens when it goes into an alarm state? We're going to create a new SNS topic, or simple notification service topic. And what that will do is it will allow us to receive emails whenever this billing alert occurs. So we're just going to create a new topic. We'll give it a name there. That will do. And we're just going to put in our email address there. And we create that topic. So what is going to happen now is that you will receive an email from AWS to authenticate or validate that that email is actually yours. So if you go to your email account, and there we can see that we've got an email that's come from Amazon, and we just need to confirm that subscription. So if we click on that, and that will confirm that subscription. So AWS need to make sure that the email that is on there is actually an email that you are responsible for or that you own. So we'll just close out of that. So we'll just scroll down. We don't need to do anything else here. We just need to click on next. We'll just give our alarm a name and a description. We don't actually need to give it a description. I'll just leave that empty. It's pretty self-explanatory what this is. And we'll click on next. So that will detail now a preview of what's going to happen and the conditions around how it is going to be triggered, and that we're going to give it a name there, P-Cody Billing Alert. Of course, yours will be different to that. So let's create that alarm. Okay, so that alarm has been created. When this is first created, you will get insufficient data because it takes time for CloudWatch to actually receive information. So it's going to monitor this, and then within 6 hours, it's going to make an assessment as to whether that billing alert should be triggered. And from there, if it is triggered, if it goes over that level that you've defined there of $10, then you will receive an email that will come from the simple notification service. Okay, so after a little bit of time, so in this situation, my account is already well and truly over that $10 limit. And so it's gone into an in-alarm state. And at the same time, I have received an email from AWS telling me that there is a problem with my account. It has exceeded that $10 billing alert limit. So that's how easy it is to actually set up a billing alert on your account. And it is something that you should always do because you don't want any nasty surprises. Like I said, everything that we're doing so far will be on the free tier, and we'll learn more about that free tier, what is on the free tier and what is not. So if something is not on the free tier, you need to make sure that you clean it up afterwards so that you don't get a bill at the end of the month. But if you forget, billing alerts are a great way to basically stop you from getting a big bill at the end of the month. So that brings us to an end, and I look forward to seeing you in the next one. In this lecture, we'll have a look at the application integration and customer engagement services. We'll then have a look at some examples, and finally, we'll finish up with a hands-on lab where we're going to use the SES service to send an email. AWS Step Functions makes it easy to coordinate the components of distributed applications and microservices using a visual workflow. For example, you may want a second function to always follow the first and only run if and when the first succeeds. And you may want to execute two functions in parallel, for example. You define your application visually as a series of steps. You define the process flow of those steps, and then you can deploy your application automatically. Amazon's Simple Workflow service works in a similar way to step functions in coordinating multiple components of a business process. For new applications, it's recommended to use step functions, not the SWF service. Amazon's Simple Notification Service, or SNS for short, is a flexible, fully managed pub-sub messaging service. What that means is that you can create a topic and users subscribe to that topic, and when you publish a message to the topic, the users that have subscribed to that topic will receive that message. It can also be used for push notifications for mobile devices. Amazon's Simple Queue Service, or SQS for short, is a fully managed message queuing service, and that makes it easy to decouple your applications from demand. What that means is that it allows messages to build up in a queue until the processing server that processes those messages can catch up with the demand. So let's have a look at an example of using these services to decouple our application from its demand. So let's just say we have an application and it's running on an auto-scaling group of EC2 instances. And that application is a process server. It's not a web server. It's processing messages as they come in. And those messages could have information on an image that needs to be processed, or a video that needs to be processed, or a cryptography problem that needs to be solved. And so those messages come in, and as that demand increases, or the number of messages coming in increases, then the auto-scaling group will also add more instances to cope with that increasing demand. So what happens if that increase in demand occurs over a 1 second period? And that is a very large spike. Our auto-scaling group cannot handle that sort of scenario because it's going to take at least 5 or 10 minutes for instances to launch and be up and running. So what happens in the meantime is a problem for us. In a similar way that a bank has a queue, and so when people come into a bank and the teller is too busy to serve them, they can build up in a queue until such point in time that the teller can reach them. We can do the same thing with the SQS, or Simple Queue Service. We can let those messages come in and they can build up in a queue until such time that our auto-scaling group of EC2 instances can get to that queue and empty out the queue. And that is great because we have now decoupled our demand from our application. And so if spikes come in, our application can handle it. But what happens when the average demand exceeds what our capacity is? So I'll give you an example. So we've got our bank, and all of a sudden we had 5 tellers, and 4 of those tellers have become sick. They've got influenza or whatever. But the same amount of people are coming through the door, and the queue is going to build up, and the queue will never decrease. It will continue to increase in size indefinitely. The same thing can happen in this architecture. For example, we might have a whole heap of unhealthy instances, and all of a sudden, our capacity cannot meet demand. And so that SQS queue is going to grow indefinitely. Or we may have done an update to our application that is faulty, and that SQS queue continues to increase. So what we can do is that we can set up a CloudWatch metric, and that will alert us with an SNS email notification that our SQS queue is continuing to grow and that we need to investigate that further. Now, normally we would use a metric on the instances to signal that those instances are overloaded and we need to increase our capacity of our auto-scaling group. Now, in this situation, that's probably not going to happen because these messages are just going to build up in the queue. And so we need a way of notifying the auto-scaling service that the queue is increasing. And the way we can do that is with, again, a CloudWatch metric that will alert the auto-scaling group that the SQS queue is too big and to put on more instances to reduce the size of the queue. And at the same time, when the queue is empty, CloudWatch can send a metric to the auto-scaling group to reduce the number of instances and terminate those so that we're not wasting those resources. Let's have a look at some customer engagement services. Amazon Connect is a self-service contact center in the AWS cloud, and that is delivered on a pay-as-you-go pricing model. It has a drag and drop graphical user interface, and that allows you to create process flows that define customer interactions without having any coding at all. Amazon Pinpoint allows you to send email, SMS, and mobile push messages for targeted marketing campaigns, as well as direct messages to your individual customers, for example, an order confirmation. Amazon Simple Email Service, or SES for short, is a cloud-based bulk email sending service. And coming up next, we're going to be doing a lab using the Simple Email Service to send an email. So make sure that you download the Introduction to AWS lab notes, and let's get into it.
In the AWS Management Console, we go to Services, and over on the right-hand side here, we've got Messaging Services. We click on SES. And the first thing we need to do is that we need to verify our email address. So we just go to Email Addresses, and we'll put in we click on here to verify a new email address. And then we click on Verify this email address. So what's happened now is that AWS has sent an email to us to verify our email. Once we click on that link, we'll be able to continue to use the SES service. Okay, so when you've clicked on the verification link to the email, you'll get a congratulations message that you've verified your email. So just click out of that and go back into the SES Management Console. If we refresh the screen, we can see that it has now been verified. So what we can do now is we can send a test email. So just click on Send a Test Email. We'll put in, what I'm going to do is just send a message from myself to myself so that I don't have to verify any further or any additional email addresses. And just put the subject as test. Let's copy that over. And we'll send that test email. And that will be happening. And so what we can do is we'll go into our email account and we'll see that that test email will have been sent. Okay, so I've just gone and checked my email account, and yes, that test email went through fine. Now, you might be questioning, what do we do now? It's one thing to send a single email, but that's not much good to us. We want to send out bulk email. Now, obviously, sending out bulk email it can be spam. So AWS are mindful of that, and so there is a process that you have to go through to apply to use the SES service to send out bulk email. So the way you do that is you go into just go into sending statistics here, and you can see there is a link there to request a sending limit increase. So just reading off there, so your Amazon SES account has sandbox access in region US East Virginia. And so that is very limited to what you can do. And so if you're going to be using this for example, in an enterprise application, then you would want to go there and request a sending limit increase. And so just click on that and it'll take you to a form that you fill out with all your details, and you just submit that to the AWS support department and they will make that happen for you. So that's all I need to show you now on the SES service, and I look forward to seeing you in the next one.
In this lecture, we're going to be running through some of the analytics and machine learning services on AWS. Amazon Elastic MapReduce, or EMR for short, is AWS's Hadoop framework as a service. You can also run other frameworks in Amazon EMR that integrate with Hadoop, such as Apache Spark, HBase, Presto, and Flink. Data can be analysed by EMR in a number of AWS data stores, including Amazon S3 and Amazon DynamoDB. Amazon Athena allows you to analyse data stored in an Amazon S3 bucket using standard SQL statements. Amazon Elasticsearch is a fully managed service for Elastic.co's Elasticsearch framework. This allows high-speed querying and analysis of data that is stored on AWS. Amazon Kinesis allows you to collect, process, and analyse real-time streaming data. Amazon QuickSight is a business intelligence reporting tool similar to Tableau, or if you're a Java programmer, similar to BERT, and is fully managed by AWS. So let's have a look at some of the machine learning services on AWS. AWS Deep Lens is a deep learning enabled video camera. It has a deep learning software development kit that allows you to create advanced vision system applications. Amazon SageMaker is AWS's flagship machine learning product. It allows you to build and train your own machine learning models and then deploy them to the AWS cloud and use them as a back end for your applications. Amazon Rekognition provides deep learning based analysis of video and images. Amazon Lex allows you to build conversational chatbots. These can be used in many applications such as first-line support for customers. Amazon Polly provides natural-sounding text-to-speech. Amazon Comprehend can use deep learning to analyse text for insights and relationships. This can be used for customer analysis or for advanced searching of documents. Amazon Translate can use machine learning to accurately translate text to a number of different languages. Amazon Transcribe is an automatic speech recognition service that can analyse audio files that are stored in Amazon S3 and then return the transcribed text. Okay, so let's have a look at using one of these machine learning services, Amazon Rekognition, for analysing some image and video. Machine learning on AWS is one of the coolest things you can do on AWS. And Amazon Rekognition is a service that just absolutely blows my mind away. The reason I say that is that 30 years ago, I used to be a young engineer and I was working in the industrial robotics industry. And back then we had a vision system that could recognise from a black and white image the difference between a triangle and a square. And back then, that was really groundbreaking stuff. And I look now over the last 30 years and where we are now compared to where we were back then, is just unbelievable. And the potential for this stuff is absolutely beyond belief. Okay, let's get into it. It's services and then to Amazon Rekognition, or it's R for just plain old recognition without the Amazon. So we scroll down to Rekognition. That'll take us into the Rekognition Management Console. And we'll try a demo. So this will take us into a lot of different demonstrations of the power of this Amazon Rekognition. So here we can see we've got a sample image of a guy on a skateboard doing a flip, and Amazon Rekognition has analysed this object in this scene, in this picture, and it's identified that there's a 99.2% probability that there's a skateboard there. And the person's a human being, he's playing a sport. We can see a lot more here. He's in a parking lot. Maybe not, he's on a road, but close enough. There's cars there. He's on a road. There's buildings. So you can see there's a lot of stuff that has been picked up in that image. So how does it get there? So if we want to use this ourselves, we need to send a request to the Amazon Recognition API, or we can do that through one of the many software development kits that are offered by AWS. So if we had, for example, the JavaScript SDK, we would have a function there that we could send this request off to. So what does a request look like? So we can see here, we're going to have our object that's in a bucket. We're going to provide the bucket name. And we're also going to provide the name of the object that is our image. When we send that off to AWS Recognition, it comes back with a response. And here it is. It'll come back with all of the labels that it's picked up. It's picked up a skateboard with 99.2% confidence. And there you can see there's a whole heap of stuff that it has picked up from that object and scene detection. Okay, so let's see how it works with an image we give it. So we'll click on upload and we'll upload our own image. I'm just going to get a picture of an elephant and upload that. And so you can see quite quickly it's analysed that image. It's found an animal, an elephant, some wildlife, and that's pretty cool. So let's have a look at the other one. So we've got image moderation. So what this does is it automatically detects explicit content. So for something for a children's site, you might want to moderate the images that are being uploaded to that site. And so this is a great way to do it. So we can see here we've got a family image. So we just click on view content. And we can see that it's come back with nothing, absolutely nothing. So we look at the response and it comes back with moderation labels, nothing. The reason it came back with nothing is that it's found nothing that is explicit or suggestive adult content. So let's have a look at the other one of the girl in the bikini. And so there we can see that we have a female swimwear or underwear, 98.7% probability that is there. And so that's a great tool that, if you really want to, look after children, if you've got a kid's website, this is a great way to do it. So let's have a look at facial analysis. This is quite a good one. So we can see there that we've got a girl. She's got her sunglasses on, but it still recognises that it's a girl. It still recognises that she's smiling. She's wearing sunglasses, and there's a whole heap of information. Her eyes are open even. It can tell with sunglasses on. I don't know how it does that. Mouth is open. And there's a whole heap of stuff there that it analysed. And we can see here it can do the same for multiple faces. And you can see that there's a male there. And so we can select each different one. So we can select this one and it says it appears to be female, 100%. 11 to 18 years old. This one here, 23 to 38 years old. So it's quite amazing that it can tell the difference in ages of people from an image. And it can also identify people. So here is where it's identifying from its database of celebrities. We've got Jeff Bezos from Amazon, and we've got Andy Jassy from AWS. And so it's got 100% match confidence there. So we're going to do this ourselves. I'm just going to upload an image of a couple of celebrities and see whether it can do it for us as well. Okay, so it's had a look at that image and it's identified that Keith Urban and Nicole Kidman are in that image with 100% confidence. I reckon that's pretty amazing actually, but hey, that's the whole thing about facial recognition, is that we're in a whole different world now that computers can recognize who we are. So let's have a look at face comparison. So here we have an image on the left of a girl and an image of the same girl with a group of other girls. And here we can see that it's identified a 98% probability that they are the same girl, and it's not the other two girls. We can do the same with a different image. And so here we can see that it's identified that it is a girl on the right. Let's have a look at another one. And it has found that girl as well in the other image. And it's identified that she's not the other two girls. So again, the facial recognition is really quite powerful. Let's have a look at text in image. So here we can see it's picked up text from an image. and it's picked up the number plate on a car. So obviously there's a lot of stuff that can happen here. You know, it's obviously if you're going to be having a toll on a bridge or something like that, great service for doing that. Let's have a look at video analysis. Okay, so here's a video. I'll just play it. We can see there's just a video from AWS Live. And it has picked up that there are two people here, and two of them are celebrities. They're both celebrities. So let's have a look at that. So we've got those two celebrities, and it's identified. There we go, Mr. Vogels and Mr. Bezos. And it's also identified some objects in there. So it's picked up the furniture and the chair, and that someone's wearing it, someone's got a beard, and it's picked up quite a bit. So that brings us to the end of this little run through of Amazon recognition. And by all means, open it up and have a play around with it yourself and try and think about what you can do with it. Because remember, this is, if you're a developer, you can use this as a back end by just using the JavaScript SDK, which interfaces nicely with this. And you can, you can come up with some really interesting ideas for applications. I'll see you in the next one. In this lecture, we'll have a look at the security, identity, and compliance services of AWS. Now, this is a very important category of AWS, and as such, there is a very broad selection of products that are available. Once we've done that, we'll finish up with a hands-on lab using the Identity and Access Management service. AWS Artifact is an online portal that provides access to AWS security and compliance documentation. And that documentation can be readily available when needed for auditing and compliance purposes. AWS Certificate Manager issues SSL certificates for HTTPS communication with your website. It integrates with AWS services such as Route 53 and CloudFront. And the certificates that are provisioned through AWS Certificate Manager are completely free. Amazon Cloud Directory is a cloud-based directory service that can have hierarchies of data in multiple dimensions, unlike conventional LDAP-based directory services that can only have a single hierarchy. AWS Directory Service is a fully managed Microsoft Active Directory service in the AWS cloud. AWS Cloud HSM is a dedicated hardware security module in the AWS cloud. This allows you to achieve corporate and regulatory compliance while at the same time greatly reducing your costs over using your own HSM in your own infrastructure. Amazon Cognito provides sign-in and sign-up capability for your web and mobile applications. You can also integrate that sign-up process with external OAuth providers such as Google and Facebook, and also SAML2 providers as well. AWS Identity and Access Management, or IAM for short, allows you to manage user access to your AWS services and resources in your account. Users and groups of users have individual permissions that allow or deny access to your resources. AWS Organizations provides policy-based management for multiple AWS accounts. This is great for large organizations that have multiple accounts and they want to manage those and the users that use those accounts centrally. Amazon Inspector is an automated security assessment service. It can help to identify vulnerabilities or areas of improvement within your AWS account. AWS Key Management Service, or KMS for short, makes it easy to create and control encryption keys for your encrypted data, and it also uses hardware security modules to secure your keys. It's integrated well with AWS services such as Amazon S3, Redshift, and EBS. AWS Shield provides protection against distributed denial of service, or DDoS for short, protection against DDoS attacks. The standard version of AWS Shield is implemented automatically on all AWS accounts. Web Application Firewall, or WAF for short, is a web application firewall that sits in front of your website to provide additional protection against common attacks such as SQL injection and cross-site scripting. It has different sets of rules that can be used for different applications. Now let's have a look at using one of the core AWS security services, Identity and Access Management, or IAM. Now, up until now, we've been logging into our account using the email address and password that we used to create that account. And that is logging in as a root user, and it is not desirable to do that. The reason I say that is that the root user will have access to everything, access to finances, credit card, access to locking people out of that account. And so that is something that cannot be compromised. Otherwise, you're in a lot of trouble. So what we do is that we lock that down. We put a very long password and complicated password on that account. And we can also have multi-factor authentication if we want to go to that next step of locking that down. Once we've locked down our root access, we can create an IAM user. And we can log in as that IAM user, and that IAM user will have permissions specific for what we need to do. And so if we, for whatever reason, need root access, we can still get that if we need to. But we log in for the most part as an IAM user, and that protects our account. So again, we go to services and we look for the IAM service. Now, once we're in there, we can go to users on the left here, and we can create a user by clicking on add user. We'll give that user a name. I'm just going to call it test. That'll be fine. Now that user can have management console access. Yes, we would like that, but they can also have programmatic access if they're going to be connecting in through a software development kit or connecting in through the command line interface remotely. So we're going to give both of those because it's going to be ourselves that'll be assuming this user. We can put in a custom password there. So I've just put in a password that I'll remember. And we won't worry about changing that password because it's for us, not for someone else. So once we've done that, then we can attach permissions to that user. So we click on Next Permissions. Up the top here, we've got Attach Existing Policies Directly. So AWS have already done the work of writing policies specifically for job functions. So if we click on that, and what we can do is we can select here Administrator Access. And that provides full access to AWS services and resources. But that does not include financial and that sort of secure account management stuff. So we can attach that policy to this user that we've created. So we click on Review, and we can see there we've got a username test, and they've got both programmatic access and management console access, and their permissions are defined in that administrator access. So it basically gives you full access to use all of the resources or all of the services. We click on Create User. So that user has now been created, and we can see here we've got an access key and a secret access key, and we can download all of this information. So if we download that now, and we can save that somewhere, and that's our credentials. So when we open it up, that file, it will have information about how we log into the management console. So before we would have been logging in from aws.amazon.com, but now we've got our own sign in link, and yours will be different. And if we click on that now, we will be able to sign in as that IAM user. So you will have your account ID, or if you've created an alias, it will be an alias. Now I've created an alias from my account called backspace-labs, but you will no doubt just have your account ID there. Put in the name of that user that we created. And then we put in the password that we created for that user as well. And if we sign in now, we should be able to get in. And so there you go. we've signed in back to where we were in the AWS Management Console. So now we don't need to use those root user credentials. So what we can do now is we can change those root user credentials. So to do that, we need to log in as the root user. So we go to our account up here. So I'm logged in as test. So I want to sign out and then log in with root access. So I click on sign out and that'll take me back to the AWS homepage. So if I go back into my account, AWS Management Console, and I get this screen that we had before. Down the bottom here is a link, sign in using root account credentials. So I'm going to click on that. And that's going to get me into my root user. So I just sign in. And there we go, we're signed in now as the root user of the account. So what we can do now is do the same thing again. We go into our account details here, but we go down to my security credentials. And what we can do now is that it's going to give us a warning that we're going to be changing the security credentials of the entire account. So that is what we want to do. So we're going to continue to security credentials. And here we can see up the top here is password. And click here to change the password name or email address of your root access account. So we click on that. And here we can go. So we can update the password. So we click on edit and we can put our current password in and then our new password, which I'm not going to change because I don't want to change it. But I'd advise you to do that and put in a really, really long and complicated password. Use a password generator to do that. And that will help to secure down your AWS account. You can also enable multi-factor authentication. It's a little bit of a long-winded process, but that will give you a little bit more security as well if you want to go down that process. So for now, I don't want to stay in the root user, so I'm going to log out. And next time I log in, I'll use my IAM user. So that's all I need to show you now on creating a IAM user. Going through the course, we're going to learn a lot more about IAM. And if you're going on to do an associate level certification, you'll be an absolute whiz of this by the end of it. You'll be writing policies. You'll be doing a lot more with this. So I'll look forward to seeing you in the next lecture. In this lecture, we're going to finish up with our overview of AWS by looking at the developer, media, mobile, migration, business productivity, and finally, Internet of Things services. We'll then finish up with a look at one of those services, Amazon Workspaces. AWS Cloud 9 is an integrated development environment running in the AWS cloud. It allows you to deploy servers directly to AWS from an integrated development environment. We'll be using Cloud 9 extensively if you go on to the Developer Associate pathway with Backspace Academy. AWS CodeStar makes it easy to develop and deploy applications to AWS. It can manage the entire CI/CD pipeline for you. It has a project management dashboard, including an integrated issue tracking capability powered by Atlassian Jira software. AWS X-Ray makes it easy to analyze and debug applications. This provides you with a better insight to the performance of your application and the underlying services that it relies upon. AWS Code Commit is a Git repository, just like GitHub, and it's running in the AWS cloud. AWS Code Pipeline is a continuous integration and continuous delivery service, or CI/CD for short. It can build, test, and then deploy your code every time a code change occurs. AWS Code Build compiles your source code, runs tests, and then produces software packages that are ready to deploy on AWS. AWS Code Deploy is a service that automates software deployments to a variety of compute services, including Amazon EC2, AWS Lambda, and even instances that are running on premises. We'll be using Code Pipeline, Code Build, and Code Deploy quite a bit if you're going on to do the Developer Associate pathway with Backspace Academy. We'll be creating a fully integrated CI/CD pipeline that will automatically package node npm packages and run tests using Mocha before deploying to an AWS environment. AWS recently acquired a media production services company called Elemental, and as a result, there are some very high quality broadcast media services available on AWS. AWS Elemental Media Convert is a file-based video transcoding service for converting video formats for video on-demand content. Media Package prepares video content for delivery over the internet. It can also protect against piracy through the use of digital rights management. Media Tailor inserts individually targeted advertising into video streams. Viewers receive streaming video with ads that are personalized for them. AWS Elemental Media Live is a broadcast-grade live video processing service for creating video streams for delivery to televisions and internet-connected devices. Elemental Media Store is a storage service in the AWS cloud that is optimized for media. And finally, Amazon Kinesis Video streams video from connected devices through to the AWS cloud for analytics, machine learning, and other processing applications. So let's have a look at the mobile services that are available on AWS. AWS Mobile Hub allows you to easily configure your AWS services for mobile applications in one place. It generates a cloud configuration file which stores information about those configured services. AWS Device Farm is an app testing service for Android, iOS, and web applications. It allows you to test your app against a large collection of physical devices in the AWS cloud. And finally, AWS AppSync is a GraphQL backend for mobile and web applications. If you're a developer and you don't know what GraphQL is, then make sure you go out and find out, because it is absolutely revolutionizing the way we think about data. So let's have a look at the migration services that are available on AWS. AWS Application Discovery Service gathers information about an enterprise's on-premises data centers to help plan migration over to AWS. Data that is collected is retained in an encrypted format in an AWS Application Discovery Service data store. AWS Database Migration Service orchestrates the migration of databases over to the AWS cloud. You can also migrate databases with one database engine type to another totally different database engine type. For example, you can migrate from Oracle over to AWS Aurora. AWS Server Migration Service can automate the migration of thousands of on-premise workloads over to the AWS cloud. This reduces costs and minimizes the downtime for migrations. AWS Snowball is a portable petabyte scale data storage device that can be used to migrate data from on-premise environments over to the AWS cloud. You can download your data to the Snowball device and then send it to AWS, who will then upload that to a storage service for you. So let's have a look at the business productivity and desktop streaming applications. Amazon WorkDocs is a secure, fully managed file collaboration and management service in the AWS cloud. The web client allows you to view and provide feedback for over 35 different file types, including Microsoft Office file types and PDF. Amazon Workmail is a secure, managed business email and calendar service. Amazon Chime is an online meeting service in the AWS cloud. It is great for businesses for online meetings, video conferencing, calls, chat, and to share content both inside and outside of your organization. Amazon Workspaces is a fully managed, secure desktop as a service. It can easily provision streaming, cloud-based Microsoft Windows desktops. Amazon AppStream is a fully managed, secure application streaming service that allows you to stream desktop applications from AWS to an HTML5 compatible web browser. This is great for users who want access to their applications from anywhere. Now, one area that is really progressing rapidly is the Internet of Things on AWS. So let's have a look at some of these services. AWS IoT is a managed cloud platform that lets embedded devices such as microcontrollers and Raspberry Pi to securely interact with cloud applications and other devices. Amazon FreeRTOS is an operating system for microcontrollers, such as the microchip PIC32, that allows small, low-cost, low-power devices to connect to AWS Internet of Things. AWS Greengrass is software that lets you run local AWS Lambda functions and messaging, data caching, sync, and machine learning applications on AWS IoT connected devices. AWS Greengrass extends AWS services to devices so they can act locally on the data they generate while still using cloud-based AWS IoT capabilities. There's some really cool stuff going on game development on AWS. So let's have a look at some of it. Amazon GameLift allows you to deploy, scale, and manage your dedicated game servers in the AWS cloud. Amazon Lumberyard, you can see there we've got some images of some pretty cool stuff. It's a game development environment and cross-platform AAA game engine on the AWS cloud. So let's have a look at one of these services, AWS Workspaces. Now, Workspaces, it will stream a Windows desktop to your end users. Now, that is great if you've got an enterprise of hundreds of employees. You can get those new employees up and running quite quickly. Now, this is not a lab, and I encourage you not to do this as a lab. The reason being is that to create a workspace is quite quick and easy, but to clean it up afterwards and making sure that you don't get a bill at the end of the month is not as easy. So probably best if you just sit back and watch me actually do this rather than take the risk of getting a bill at the end of the month. So first off, we go to Services, and then we go to Workspaces, and that will take us in to the Workspace Management Console. And if we've never created a workspace before, we'll get this screen here. So we can click on Getting Started or Get Started Now, and we'll do the quick setup. And we're going to use a standard with Windows 10. And what we've got to do now is that we've got to put some users in. So I'm just going to put myself in, or put someone in as a user. Okay, so that will actually now launch or create a workspace for us. And this user, Joe Blogs, will be able to access that just the same as they would access that on a normal desktop environment. So we'll now click this Launch Workspaces. So we can see now it's now being launched. It's not an instantaneous action. It will take quite some time before this workspace appears. Okay, so after about half an hour, we've got this available. It normally takes about 10 minutes to get to the pending status, and then about another 20 minutes or so to get to the available status. So once it's available, what we can do next is that we can get our user that we've created, and if we created multiple users, they would be listed here, and we can invite that user. So we just click on Invite, and it will send an invitation email with a link So we click on Send Invite. And that will be sent. And then once that's done, then that account for this desktop environment will be validated. So what we can do now is we can expand this here and we can go to the client's link. So we go to that. And what we can do from here is that we can download the application that will install on our desktop that will connect to this desktop stream. So we can download it for Windows, Mac, tablet, whatever. But once we've downloaded that, we're going to have an environment that's going to be very similar to a native environment on our desktop. So once you receive that invite email, you'll get a screen like this where you can put your password or set your password there. Once you've done that, click on Update User. And what you can do then is install the Workspaces client, which is what I'm going to do now. And then you'll get a key to actually log into that. Okay, so I've installed Workspaces desktop client and I've got my email that has my registration code, and all I need to do is put that in there and register. And now I just sign in with my credentials. Okay, so now we have a fully blown Windows desktop environment, Windows 10 environment. So if we go to here and we go to View and we go Show Full Screen, we're going to have something that is identical to a native desktop environment. So I'll just do that now. And there we go. We've got a full-blown Windows desktop. There is nothing to distinguish that from anything else. So we've got all our applications that will be part of that workspace down here. And if we want to get out of that, we just go put the mouse to the top of the screen here and a little drop down will come. We just go back to View and Exit Full Screen. So now we need to, first off, we need to remove this workspace. So we select the workspace and we select Remove Workspaces and Remove Workspace. So that will take quite a while for that to happen, probably around about 10-15 minutes. But even when that workspace has been deleted, the Workspaces application has actually created a simple AD directory for us. And when we delete that workspace, we're still going to be billed for that. So we can see here, note, Simple AD and AD Connector are made available for you free of cost with Workspaces, Workmail or Workdocs. If there are no workspaces being used for 30 consecutive days, you may be charged for this directory as per, the pricing terms and conditions, blah, blah, blah. So we don't want that to happen. So I'm going to go into it now and delete that all as well. So the first thing I'll do is go into Directories. I'll select that. And I'll do Actions and Deregister. Okay, so that is, it's staying registered now, but it'll take some time. Again, nothing happens quick with Workspaces. Okay, so now after 5-10 minutes, it's now no longer registered. Okay, we can see there, no longer registered, but it's still there. We're still going to get billed for it. So if we go to the directory service, so we go to Services, and then Directory Services, we will see that it is still there. So that what we need to do now is we need to delete it from here as well. So we can't just directly delete this here because it's still got, if it would have still had that association in here, we wouldn't have been able to delete it, but now we can delete it. So we click on Delete and we just need to put the name of it there. So I'm just going to copy that over. Okay, so that status is now deleting. So that has cleaned that all up for us. And that brings us to the end of this hands-on session. Again, it's not a lab. I don't recommend that you actually use this unless you are thinking about using this with your corporation or something like that. So I'll see you in the next one. Elastic Beanstalk, it's one of AWS's deployment services, and it allows you to deploy your applications to complex architectures on AWS. And it does this without you having to worry about the underlying architecture that is behind that. Elastic Beanstalk, it looks after everything for you and you just need to worry about writing your code. We'll also talk about how Elastic Beanstalk can create highly available and fault-tolerant architectures and what that actually means. And then finally, we'll look at the different deployment options that are available on Elastic Beanstalk. Elastic Beanstalk, it's been around for quite some time, was first launched in 2011. It allows you to quickly deploy and manage applications on environments, and those environments are launched for you without you having to worry about how it all works. It'll automatically handle capacity provisioning. It'll launch a load balancer for you if you need that. It'll auto scale for you, and it can also implement health monitoring so that if one of these instances that are launched becomes unhealthy, it can replace those automatically for you. If you need to change your code after you've deployed it, it's quite easy to upload new versions of that code, and that can be done through the console or the command line interface. And also complete environments can also be redeployed if need be. Your application that you're deploying could be a Docker container. It could be raw code. It could be Node.js, Java, .NET, PHP, Ruby, Python, or Go. You just supply your code and Elastic Beanstalk will deploy that for you and it will provision that Node.js or whatever environment for you automatically. Or it could be a service such as Apache, Nginx, Passenger, or IIS. The Elastic Beanstalk process, it starts with us going through an application creation process where we will first off upload a version of our software or our code or whatever it is. And then Elastic Beanstalk will launch an environment, and that will consist of EC2 instances, or it could be a single EC2 instance. It could be a multi-AZ environment, but we define that for Elastic Beanstalk and it will do that automatically for us. From there, we will have our environment launched and our code will be running on that environment. Now, if we find that we need to deploy a new version of that code, we can deploy that to that existing environment or we can create a whole new environment. It doesn't really matter. So if we deployed it to our existing environment, then when that environment has gone through that update process and the new version is deployed and running, then the environment will feed back to the application to notify that that new version of your application is actually running. One of the big advantages of Elastic Beanstalk is that it can create a highly available and fault-tolerant architecture without us having to worry about how to actually do that. So what is a highly available and fault-tolerant architecture? So here we've got the AWS cloud. And as we know, it's divided up into regions, and those regions are divided up into availability zones. So if we have our architecture distributed across multiple availability zones, if one of those availability zones goes down, our infrastructure will still continue to operate and serve requests. Now, our virtual private cloud, that will span the entire region, so it will span multiple availability zones. And so what we can do is that we can launch instances into both of those availability zones, and that's going to give us high availability if one of those availability zones goes down. Now, in order for our architecture to respond to spikes in demand or increases in demand because an availability zone goes down, what we can do is we can launch our instances using an auto-scaling group. So if demand on one of those or a group of instances increases, the auto-scaling group will add instances to accommodate that. And vice versa. If the demand goes down, we will reduce our number of EC2 instances. And that allows for elasticity in our design. And finally, to receive requests from the outside world and to distribute those requests to those multiple instances, we're going to need an elastic load balancer to do that. And that will also have the advantage of conducting health checks on our instances so that if communication breaks down between the elastic load balancer and our EC2 instance, then our auto scaling group will automatically add additional instances, and that creates fault tolerance in our architecture. Just the same as you've got a number of options available for architecture that you're deploying to, such as a single EC2 instance or a highly available and fault-tolerant architecture across multiple availability zones, you've also got a number of different deployment options that you can use. So for example, if you've got 20 EC2 instances, an all-at-once deployment will deploy that across all of those 20 EC2 instances all at once. The downside of that is going to be that while that is occurring, your architecture won't be able to respond to requests. So that's obviously not a good thing. So another option there is to do a rolling deployment, and that will deploy your application to a single batch at a time. So what that means is that if you've got 20 EC2 instances, it can deploy that to, say, 2 at a time. So you're not going to be down by much. You're just going to be down from 20 instances down to 18 instances, but your architecture will still be responding to requests. You can also do a rolling with an additional batch. So what that will do is that if you've got, again, 20 EC2 instances, it will temporarily increase to 22 while you're doing those 2 deployments across those 2 EC2 instances. And that way you're still going to have your capacity at 20, which is what you have designed for. The other option there is an immutable deployment, and that is a bit of a variation of the all-at-once. So it's still doing an all-at-once deployment across your 20 EC2 instances, but while that's going on, it's going to deploy another 20 EC2 instances. So temporarily, you're going to have 40 EC2 instances. So it's going to double up a lot on your capacity, but through that period where your environment is being deployed, or your new version or whatever is being deployed to that environment, you're not going to be suffering any downtime. And finally, we've got blue-green deployments, and they will have 2 environments that will be running your application under the one Elastic Beanstalk application. And so what that is you will have a blue environment and a green environment. One of those could be a development environment, and the other one could be your production environment. So when you get to the stage where your development environment is ready to go to be deployed, to deploy that, all you simply need to do is to switch over from one environment to the other environment. And then your old environment will then become your new development environment. And so that is very straightforward with Elastic Beanstalk, because what it does, it will simply allow you to switch the domain names for those 2 environments automatically for you. And so that makes sure that your changeover doesn't involve any downtime for returning of requests. Later on in the course, we're going to learn a lot more about blue-green deployments and how to deploy those across Elastic Beanstalk. But coming up next, we're going to use Elastic Beanstalk to deploy a highly available and fault-tolerant architecture. So make sure that you download the lab notes for this one, and I'll see you in the lab. In this lab on Elastic Beanstalk, we're going to be using the Elastic Beanstalk service to deploy a Node.js application and deploy it to a highly available and fault-tolerant architecture. So starting off in the Elastic Beanstalk console, again, we get there from Services and Elastic Beanstalk. Once we're there, we can see a welcome screen there if we haven't got any Elastic Beanstalk environments already. What I'd like you to do now is just click on Get Started. And we'll give our application a name. We'll select Node.js as our platform. And we're just going to use the sample application that AWS use. And we're going to click on Configure More Options. Now, if we didn't click on Configure More Options and just clicked straight on Create Application, it would launch our environment as a single instance. So it wouldn't be a highly available and fault-tolerant architecture. And so as we can see here, our capacity is just a single instance, and we don't have a load balancer. So what we need to do is we need to select High Availability, and there we can see our capacity has changed, and it's going to be in an auto-scaling group that will have instances ranging from 1 to 4, and we can change that as well. And also we can see there that we've got a load balancer as well. So what we'll do is we'll click on Create App. And what it's going to do, it's not only going to create that Elastic Beanstalk application for us, it's going to create an environment to launch our code on, and that will be a highly available and fault-tolerant architecture. Okay, so after a certain amount of time, we've got there, our environment has been launched and we've got the big green tick there. Now what we can do is we can go to this endpoint up the top here, which will be the URL for our application, our web application. So we click on that, and there we can see that is the sample Node.js application from AWS. Now that will be deployed to a HA and FT architecture. What that means is it will have an auto-scaling group, and EC2 instances will be launched by that. And it will also have an elastic load balancer as well. So let's just make sure that that has actually occurred. So we go to services, then go over to EC2. And if you remember, we had our auto-scaling group was varying between 1 and 4 depending on demand. So there we can see we've got one instance running. Now if we scroll down, we should be able to find a load balancer there as well. So there we go. We've got our elastic load balancer there that has been created by Elastic Beanstalk, and it's got one instance in service. We should also have an auto-scaling group. And there we go, we've got an auto-scaling group as well. And there we can see it's got a desired capacity of 1, which is what we're at now, and a minimum to maximum of 4 depending on demand on those instances. So what we'll do now is that we've pretty well finished the lab. What we need to do now is clean this all up to make sure that we don't get a bill. So the best way to do it is not to go in and delete resources. What you need to do is go into all applications and then just select that application here with actions and delete the application. So that will delete your application, and it will also delete that environment that was created by Elastic Beanstalk. So we click on delete. So it doesn't look like anything's happened, but if you click on that environment, you will see that it is now terminating your environment. And after a few minutes, all those resources, that auto-scaling group, that elastic load balancer, the instances, all will be removed from your account and you won't get billed for that. So that brings us to the end of a pretty straightforward lab, and I look forward to seeing you in the next lecture. In this lecture and follow-up lab, we're going to be looking at how we can connect to our AWS services and resources using a command line interface. So instead of having to use the AWS management console as we've done before, we can use text commands to achieve a lot of what we would normally do with that graphical user interface. We'll start off by looking at the back-end service that makes this happen, and that is the AWS Application Programming Interface, or API for short. Then we'll look at the number of different command line interface applications that we can install on our computer that will allow remote access to those services and resources. We'll also look at the AWS Cloud9 service, and we'll discuss why I primarily use this for anything to do with the command line interface and the security concerns around not using AWS Cloud9. And finally, we'll finish up by having a lab on using the Cloud9 service with the command line interface. When you're using the AWS Management Console like we've done in the past, AWS uses an application programming interface to enable that communication between your remote computer and the AWS services and resources. So how that works is that the AWS Management Console that you have been using is simply an application that is running on your browser, and it is sending HTTP calls backwards and forwards to this application programming interface backend on AWS. Now, the documentation is available for the AWS API for many services, for example, for the S3 API, for the EC2 Query API, but not for everything. So if you wanted to create your own application and there wasn't a software development kit for that language you're using, I can't imagine what language that would be, because there's certainly a very broad range of software development kits that are available, but it is possible for you to send HTTP calls to the API, provided you have that authentication done beforehand to actually do that. So It provides that back-end mechanism for that communication. And it's utilized again by the AWS Management Console. And we'll also use it with the AWS Command Line interface. So that again is an application that's running on your remote computer that will be sending HTTP calls to this API back end. Also, there are a number of software development kits that wrap the API up into libraries that can be used with, for example, JavaScript for PHP and Python and the like. And so you don't have to actually know how to do these HTTP calls. You just need to know how to use that software development kit. And the documentation for that is, of course, brilliant. And many other AWS services also use the API for communication within the AWS cloud. API calls to AWS can only be made by authenticated users with valid security credentials. For example, if you're using the Management Console, you would have been authenticated through your username and password. If you're using the Command Line Interface application on a remote computer, then you would need to download an access key ID and secret and use that for authentication with AWS. If you're using an application on your browser that has been developed using one of the many AWS software development kits, then normally you would be issued with IAM temporary credentials. So what that means is that this application that you have may use login for Google, may use login for Facebook or whatever, and it might use your Google account or your Facebook account to authenticate you, and then that will be issuing temporary credentials for you to access the AWS resources through that browser-based application. And finally, we can actually log all of these API calls using the AWS CloudTrail service. So that's great if we have any security issues or any performance issues. We can go back through those CloudTrail logs and make sure that there's nothing untoward going on there. A picture tells 1,000 words. So how does this all work? Down the bottom there, we've got our AWS cloud that we want to connect to using our remote computer. And so that remote computer will be sending HTTPS API calls to the AWS cloud to get information from that AWS cloud and to issue instructions to the AWS services. So the first way we can do it there is we could have an IAM user, and that user will have a username and password. And they can use that username and password to log in to the AWS Management Console that is running inside of their browser. And the AWS Management Console running on that remote computer will then issue those API calls to the AWS cloud. The second option there is that we could have an IAM user download IAM credentials in the form of an access key and a secret to go with that access key. And so if that is presented to the AWS Command Line Interface application that is running on that remote computer, that will authenticate that IAM user, and that IAM user will then be able to issue Command Line Interface commands to the AWS cloud. And finally, if we've got an external user, so this user doesn't have an AWS account. For example, you might have an application like Dropbox, for example, and you have millions of users, and it's not practical, or it's actually not even possible to create 1 million IAM users. So you need to be able to somehow authenticate those users and to allow those users to temporarily access the AWS cloud. So you would use an application that is running using the software development kits, and that application could authenticate you using an OAuth authentication service. For example, it could use the AWS Cognito service. It could use Google, log in with Google, or log in with Facebook to authenticate you. And from that authentication, you will have limited and temporary access through that remote computer to the AWS cloud. Now, to start using the command line interface, the first thing that you need to do is that you need to have an application running on your computer that can allow that to happen. So the AWS standard CLI application, it's available for download for Windows, Mac, and Linux. And it allows those API commands to be sent to AWS using the Windows command line or a Linux or Mac terminal application. There is also the AWS Shell application, which is a cross-platform standalone integrated shell environment that is written in Python that can provide even more features and more automation features to the CLI application. And finally, we've also got the AWS tools for Windows PowerShell. So you can run CLI commands within Windows PowerShell and at the same time use all of those automation tools that are available within PowerShell. Now, if you want to have a look at all of those CLI tools that are available, just go to the AWS website, aws.amazon.com/CLI. The AWS Cloud9 service is an integrated development environment, or IDE for short, that is running on an EC2 instance inside one of your VPCs, and you access it through the AWS Management Console. The Cloud9 service has a lot of tools already installed, so it also has the AWS CLI application pre-installed. Now, I predominantly use the AWS Cloud9 service for anything that requires CLI commands to be sent to AWS Cloud. The reason being is that it provides increased security because I don't have to download IAM credentials and have them sitting on a computer to be able to access that service. And that's very important because if those credentials are compromised, someone can not only use it with the CLI application, they could create their own application using a software development kit, use those IAM credentials, and could run bad malicious scripts that could cause a massive amount of damage and a massive amount of financial impact to your AWS infrastructure. Now, you may well ask, but what about the username and password that we use to connect to the management console? What if that gets compromised? Doesn't it have the same effect? And yes, you are correct. But coming up in the IAM section of this course, we'll be talking about how to implement multi-factor authentication on IAM accounts. So what that means is that if these username and passwords are compromised, they cannot be used to log into your account because there is a secondary, a multiple factor authentication process that also needs to be followed. Okay, so that brings us to the end of our discussion on the command line interface. Coming up next, we're going to be getting our hands on with the command line interface. So I look forward to seeing you in the lab. In this lab, we're going to be getting our hands on with the command line interface. We'll be creating a Cloud9 environment and using the terminal of that Cloud9 environment to send CLI commands to AWS. We're going to issue a command that will create an S3 bucket. We'll also issue commands then to upload an object and then delete that object. And finally, we'll issue a command to delete the bucket and clean it all up. Okay, so starting off in the management console, we get to the Cloud9 console by going to Services and Cloud9. And that will bring us to this landing page here. If we've already got Cloud9 environments already set up, you'll have a different screen here. But if you haven't used Cloud9 before, this is what you'll be presented with. So we'll click on Create Environment. We'll give our environment a name. We won't worry about a description. It's only optional, and we'll click on Next Step. So we're going to be creating a new instance to run this Cloud9 application on. And we're going to select a T2 micro instance for that. We're also going to select the Amazon Linux AMI because it's got a lot of tools pre-installed on there, including the command line interface. What we've also got here is a cost saving setting. So if we're not using this service for whatever reason, instead of getting billed for that EC2 instance, it will go into hibernation mode and will only be billed for the drives that are attached to that instance. We won't be billed for that compute capacity as such. So that is a very good thing. We'll leave that there so that after 30 minutes, it will go into hibernation. When we go back into this, it will come out of hibernation if we haven't used it. Click on next step. And that's how easy it is to create a Cloud9 environment in your default VPC. And we'll click on create environment. Now, after a few minutes, the EC2 instance will be launched and that Cloud9 application will be running, and we'll have the IDE operating within our browser. Okay, so after about 5 minutes or so, we've got our Cloud9 integrated development environment up and running. So on the left-hand side there, we can see that we've got a tree view of our file structure within this EC2 instance. So that's great. So we can actually, from there, we can upload files quite easily just by simply dragging and dropping them onto a form. Down the bottom there, we've got a bash screen. So that's a Linux terminal console. And from there, we can start issuing commands through our EC2 instance to the AWS service. And in the center there, we've got tabs, which will allow us to view files and modify files. So that is our editor as such. Now, if we want to change this, so yours will probably be a quite light and bright user interface. I like a dark one. So what you can do is just go into this toolbox icon here, this sprocket, and just click on that for the preferences. And if you scroll down and you go to themes, you can select, so by default, I think you have this flat theme, which will be that one there, but you can change it to a darker theme. And I like this dark gray one here. So if you like the dark gray, you can change it to that quite easily. So we'll just close out of that now. And we'll start to issue some commands and see how we go. Now, the first thing that we need to do is to check whether the AWS command line interface tools are installed. So we do AWS -- and version. And there we can see we've got the latest version of our CLI in there. So what I'll do now is I'm going to issue a command that is going to create a bucket on our AWS account. So the command there is AWS for the CLI command, S3 for the S3 service, MB is the command to make a bucket, and then we do S3:// and the name of that bucket. So I'm just going to give it a unique name. Now you'll need to have a different name to this. It will need to be unique for a bucket, and we'll click on enter. And so there we can see that that has successfully created a bucket for us. So if we go into the S3 console, we'll be able to see that that bucket has been created. But before we do that, how about we upload a file? So first off, what we'll do is we'll upload a file to this EC2 instance, and we're going to be doing that by going onto the tree view here. And what we can do is go to File and Upload Local Files. And then all we need to do is just drag and drop a file. So I'm just going to drag and drop the lab notes onto this form, and then that will upload that to this EC2 instance. Okay, so there on the left-hand side, you can see that we're uploading it, and very quickly it has uploaded that to our EC2 instance. So I'm just going to shorten that name a little bit and just going to call it notes. And that will be fine. Okay, what we can do now is that we can issue a command that will copy that file over as an S3 object to that S3 bucket. So the command we need to use is the AWS S3 CP command. So AWS S3 CP, and then the actual file name, so it will be notes. Now remember, file names are case sensitive, so this has a capital N, so I'm putting a capital in there. .pdf, and then the name of the bucket, which will be S3, and then that name of the bucket. So S3 colon / and that bucket name, CLI. Okay. So there we go. AWS S3 CP, the file name, and then the bucket name there. Click enter. And there we go. It's uploaded that notes.pdf to that bucket. So if we go into the management console for S3, we'll be able to see that uploaded object inside of that bucket. Okay, so we'll do a new tab here and just jump into the management console. So there we go. So if we jump into the S3 service, have a look for that bucket. There it is, CLI Pukoti. And there we can see we've got that bucket has been created. Our notes.pdf document is there. Everything seems fine. So what we'll do now is we'll clean it all up by deleting that notes.pdf. So the command that we use is AWS S3 RM and then S3 and colon / and then the name of that bucket and then / the name of the actual file itself and enter. So there we can see we've successfully deleted that. And if we go to this management console and if we refresh the screen, we can see that now the bucket is empty. So bucket's empty, we can now delete it. So the command that we use is AWS S3 and RB to remove that bucket. And then simply the name of that bucket. Okay, so it's removed that bucket. So that's pretty well all I want to show you as far as the command line interface goes, because it's a very, very powerful tool that can be used with a whole heap of different services. So if you want to know more about the CLI or you want to see the documentation, just go to the Amazon website, so aws.amazon.com /CLI. And then we can go to the CLI reference. Okay, so that will have a whole heap of different commands that are available for the different services. So you see the available services is absolutely massive. So we'll scroll down to what we've been using, which is S3. So we see there we've got two. We've got S3 and we've got S3 API. So the S3 API is far more powerful, and that takes advantage of all of the API commands that are available, whereas the S3 commands only have very shortened, limited use. So they're more for quick things to be done. So CP instead of, copy and then having this big long string. So let's have a look at that. So we go into the S3 API, and if we want to create a bucket, we can scroll down and we can see the command there. It's quite long and lengthy. So we can see there, it's a lot more verby than using just a simple CP command, but it's a lot more powerful. You can do a lot more with it. So I'll just go back and we'll have a look at the S3 commands. So we can see here, we don't have a lot of commands available. So they're the only commands that are available using that S3. So if you want more than that and you want the full capability that you have with the S3 service, you can use the S3 API commands. So let's have a look at one of the ones that we've been using there. So CP, and we can see there, it's going to have different options and whatever that are available. It'll have an example if we scroll down. Okay, so there we can see we've got an example. Now what you do there is that we've got, first off, we define what that file, that local file is, and then we define where we want to send it to. So we just sent it to my bucket, but if you wanted to change the name of that, because you can see here we're going from test to test2, you can actually put that extension to that bucket name there. So that's pretty well it as far as that S3 stuff goes. There's not really a lot to learn with that S3, but again, go to the document page and have a look at it and see if you can play around with some of these different sorts of commands, and you'll find it is quite a powerful thing to use. So that brings us to the end of the lab. First thing that we need to do now is just clean up this development environment. So what we do is we click on AWS Cloud9 here. We go to our dashboard. And there are our environments. Now I've got 2 environments here. You'll just have one. Select that environment and delete. And just type in delete. And that will eventually delete that EC2 instance and that complete environment and bring you back so that you're not going to get a bill at the end of the month. That brings us to the end, and I look forward to seeing you in the next one. I'd just like to very quickly introduce you to the AWS free tier. Now, up until now, everything that we've done with these labs has been covered under that free tier, and we won't be getting a bill for it, provided we deleted everything after the lab. We won't experience a problem there. So what I'd like to do now is first of all show you how to get to the AWS free tier website. So you go to aws.amazon.com, the AWS website, and it's simply /free. Now what we can see is that there are some things here that are free for 12 months, some things that are always free and trial. So what that means is that if we signed up for our account 3 months ago, there are some things that are going to be free for another 9 months. So they're only free for 12 months from the time that you first opened your AWS account. We also have some things that are always free. So provided we stay below a certain limit of that service, we're going to get that for free as well. And that won't be affected by the 12-month period at all. We also have short trials of services as well. Now, we can have a look here and just have a look at the product categories. So I'll just click on that. So under compute, we've been using Amazon EC2, and we'll be using it quite a bit throughout this course. And that will give you 750 hours free for 12 months per month. So what that means is that we can have 750 hours per month of T2 micro instance, and that will expire 12 months after signing up for AWS. Now, the big thing to remember is that this is only for a T2 micro instance. If you have anything bigger than that, doesn't matter how much you use, you're going to get billed for it. And also to consider is that a smaller instance like the T2 Nano will not be covered under the free tier. It is specifically for the T2 micro instance. The other thing to take into consideration, if we're launching a highly available and fault-tolerant architecture, where we're using, say, 2 T2 micro instances, that will double up our usage. So instead of having 750 hours of usage, if we're using 2 of the T2 micro instances, we're only going to be able to have 375 of those hours available. So the more instances you use, the less hours you're going to have. And the same with our database service. So with RDS, we've used that as well. We're going to get 750 hours of that. And that is, again, only going to be for T2 micro. And with storage and content delivery, we're going to be using S3 a lot. And again, we're going to get 5 gig of standard storage under that free tier. So let's have a look at the things that are always free. So under Amazon CloudWatch, so we have 10 custom metrics and 10 alarms. So provided we stay below that, that's not going to cost us anything. And that doesn't expire after 12 months. So it's always free. And DynamoDB, 25 gig of storage, always free. Amazon SES, 62,000 outbound messages per month. Provided we stay under that for the month, we're not going to incur a charge for that. And we also have trials. So you need to be very careful with trials. So for example, with Amazon Redshift, that is a quite an expensive service. So if you look there, you've got 750 hours of DC2 large hours per month for 2 months. But if your account is already over 2 months old and you sign up for, or you actually start using Redshift, you're going to get billed for it, and you're going to be billed for quite an expensive instance as well. So that's the AWS free tier. So what I'd recommend you do is go to this website, have a look around, see what's free. As you're working through the labs, if you have any doubts about something being free, then just go to here and check it out, and I'm sure it'll be fine. So we do try to stay under this free tier throughout the course, but things such as buying a domain name will incur a cost. So that's all I want to say about that for now, and I'll look forward to seeing you in the next lecture.